Good morning everyone. Today I am going to discuss the chapter Gravitation, which is mentioned in class 9th. So in this chapter we will first discuss the two terms, that is gravitation and second term is gravity. So let us discuss about this term gravitation. What do you mean by gravitation? Gravitation is basically a type of force. Gravitation is basically a type of force which is acting between the two objects, that is present in the earth, and this force acts because of their masses. Those objects, any objects which present in the universe that are having masses, then this force will act between those two bodies. The other name of this gravitation is called gravitational force. Gravitational force. And the third name is force of gravitation. Force of gravitation. So it is basically a type of force which will act between any two objects that are present in the universe and have mass. Second important point, the nature of this force is always attractive. Those objects which are having masses, in that case this force will act, and the nature of this force is always attractive. So now come to some example. We will take some examples regarding gravitational force, that the force between any two objects. For example, if we take a marker and duster, if we take a marker and board, and between two object benches, that is benches, then this force will act, that gravitation force will act. Then someone says that if that force will act, then why the body cannot move towards each other? So the next important point is that the magnitude of this force is quite small as compared to other forces. For example, in case of magnetic force, in case of strong nuclear force, in case of weak nuclear force, the magnitude of this force, that is gravitational force, is quite small, although it is the weakest force in nature. So if we take the example, the force between pen and board. Now come to the next topic, that is gravity. So what is the basic difference between gravitation and gravity? Gravity is also a type of force. But when the two bodies are interacting and the force which act between them is called gravitation, but it is a spatial time. In the gravity, if one of the body is earth, if one of the body is earth, in that case the force of gravitation is called, gravity. Other name, force of gravity. and the direction of this force and the direction of this force, direction of gravity is always towards the center of the earth, towards the center of the earth. For example, force between a stone and earth, force between a stone and earth. So in that case, this force is called force of gravity. The stone will move toward the center of the earth. The direction of this force is toward the center of the earth. So this is the basic difference between gravitation and gravity. In gravity, out of the two bodies, if one of the body is earth, and in gravitation, that two bodies which are interacting, then there will be a force that act between them because of their masses. Now, in the series, we will come to the next point, that is universal law of gravitation, that is proposed by Sir Isaac Newton. Now we will discuss next topic, that is universal law of gravitation. Universal law of gravitation. Other name is Newton's law of gravitation. Which is proposed by Sir Isaac Newton. So what Newton sir assumed in this diagram, now we will discuss the universal law of gravitation, or its other name is Newton's law of gravitation, which is proposed by Sir Isaac Newton. In this law, he considered the two objects of mass m1 and mass m2, and the distance between their centers is small r. The distance between the center is small r, then there will be a force which will act between their centers, That force is called gravitational force. And he postulated and he stated that every object in the universe attract every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. According to him, this force is proportional to the product of their masses, that is m1 into m2. This is the equation first, and inversely proportional to 1 upon r square. This is the equation second. On combining we get f proportional to m1 m2 upon r square. By replacing the proportionality sign, we will get a proportionality constant, that is capital G. So this is the expression which Newton's are derived if the two objects are placed at a distance small r from each other having masses m1 and m2. Now this proportionality constant is called universal gravitational constant. And its value is 6.673 into 10 to the power minus 11 Newton meter square upon kg square. This value remains constant everywhere or throughout the universe. That is why it is called universal gravitational constant. Now there is one important point. Sometimes a student replace the sign minus and he or they can put plus sign. So why minus sign is important? Because as we have discussed that this is the weakest force in nature. If you place plus 11, then it will magnify or multiply your result by 10 to the power 11. So the magnitude of gravitational force is quite large, which is not possible. The value of gravitational force is quite small. So you have to take this minus sign while calculation. Next, now we will discuss the calculation of unit of capital G. As we know that the formula F is equal to G m1 m2 upon r square. So keeping this term capital G on one side and take all other terms on other side. Capital G is equal to F into r square upon m1 m2. As we know that the SI unit of force is Newton and the SI unit of distance is meter e power 2 and kg into kg. Now the final SI unit of capital G, Newton meter square upon kg square. Some more important points: spatial features regarding the universal law of gravitation. First one is gravitational force are central forces. Second point, gravitational force are the weakest force in nature. Third one, gravitational force follow Newton's third law of motion. Fourth one, range of gravitational force is infinity. So first one, that gravitational force are central forces. So central forces are those forces which are acting on the line, that is joined by their centers. Between the object and the other fixed point or reference point. So these are called the central forces. They are acted along the line that is joined by their centers between the object and the reference point, and same in the case of second body. Central forces do not cause any torque. Do not cause any torque. We will discuss this point further. It is the weakest force in nature out of all the forces. Third, it follows Newton's third law of motion. Newton's third law of motion means equal magnitude, opposite in direction. Equal magnitude and opposite in direction. Force on 1 because of 2 and force on 2 because of 1. So opposite in direction. Equal in magnitude, this means that magnitude of F12 is equal to magnitude of F21. This will represent the sign of modulus. It will tell the magnitude of this force. The magnitude of both the forces are equal, and in second case, the direction of F12 and the direction of F21 are opposite to each other. You can see this from diagram. The direction of F12 and F21 are opposite to each other and they are equal in magnitude. So Newton's law of gravitation follow Newton's third law of motion. And last point, range. The two objects which are placed at infinite distance, still that the gravitational force act between them. These are some basic key points regarding universal law of gravitation. And last important point, limitation. This law is valid only for point objects. Only for point objects. It is not valid. For extended objects. It is not valid for extended objects, big size objects. How to apply universal law of gravitation for extended objects, we will discuss further in senior classes. I hope you have understood the topic. Thank you. Have a great day.